Hello students, welcome back to today's class on coordinate geometry, and we are in lecture number 2 on that. And in the last class we have discussed what is an axis, what is a plane, and how to plot points, and also how to find distance between 2 points, right? So let's continue our discussion with the same thing. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's class. Okay, so the first one that we're going to discuss is to find the distance. Yesterday we have discussed the same thing, but I didn't tell you the answer when we round to 2 decimals. Okay, the distance between these 2 points, you know the formula. This is x1, y1, x2, y2. x1, y1, x2, y2. So that is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So that will be equal to root over x2 minus x1 whole square minus 4 minus 1 whole square plus y2 minus y1, 4 minus of minus 3, 4 minus of minus 3 plus 3 square. So that will give you 4 plus 1, 5 square is 25, plus 4 plus 7, 4 plus 7, 7 square is 49. So that will give you 4, 5, 6, 74. As if we have discussed this question, we got root 74, but we haven't discussed what is the value of root 74 rounded to 2 decimals. Okay, so how to find the square root of 74? Once again, let me recall the procedure which we have already learned in the previous classes, right? So write that as 74, next 0, 0 and 0, 0, because we need to round off to 2 figures. So keep it as 0, 0 and 0, 0, right? So now start dividing with the nearest square. Nearest square for that is 64, right? So what is the square root of that? 8. So 8 8s are 64. 8 8s are 64. So we're left with 10. We're left with 10. Okay. Now add the same number to it. The same number 8 to 8. So it will get 8 plus 8. 8 plus 8 will give you 16. The next process is to take this decimal point here and bring this 2 zeros here. Decimal point there and 2 zeros to here. Now, we need to express one number here such that, let's say if you replace 2, that 162 into 2 should be the nearest number to 1000. 163 into 3, let me check 166 into 6. 6 is 36, 6 is 36, 39. 6, 1, 6, 7, 8, 9. That is very near to 1000, right? So 166 into 6 will give you 166 into 6 will give you 996. So that will give you, right? So now you need to bring more zeros, double it down. Okay, but this is not required. You still need more zeros because it's already 166 here, right? So now add the same 6 to this one. As we have added 6 here, add the same 6 here, we get 172, and you need to replace one more value which is greater than 400. So we cannot bring it. So you need to bring more zeros. For that, you keep 1 0 here and double 0 here, and now you can continue. But as it was given to round it to 2 decimals, it is enough to say that it is near to 8.60. Okay, the square root of 74 is near to 8.60. You need to solve further. You need to go for 172 maybe into maybe 10 times, 9 times 9 or whatever it is, whatever we get. Okay. So based on that, we need to get the next further value. So we can go with 172 into 2 maybe. Alright, whatever it is. Okay. So that is how you can try to do this one. So we can try to bring the root 74 value which is near to 8.6. As we have discussed this, right? So let's move forward for the next one. If the distance between the 2 points x, 7 and 1, 15 is 10, find the value of x. Distance between x1, y1, x2, y2. x1, y1, x2, y2. It is equal to root over x2 minus x1 whole square or x1 minus x2 whole square, whatever it is. X minus 1 whole square plus 7 minus 15. How much is that? 8. Minus 8 or plus 8. Doesn't matter because we have a square. So plus 8 square is given as a 10. So squaring on both sides. X minus 1 whole square plus 8 square is 64 is equal to square of 10 is 100. Square of 10 is 100. So x minus 1 whole square is equal to 100 minus 64, which is 36. 100 minus 64, which is 36. X minus 1 whole square is equal to 36. So from here, x minus 1 equal to, when you remove square, you get plus or minus. So plus or minus root 36, you will get x minus 1 is equal to plus or minus 6. So x is equal to plus or minus 6 plus 1. So x equal to 6 plus 1 and minus 6 plus 1. X equal to 7 and minus 5. X is equal to 7 and minus 5. So that is how you can try to find the value of x. Yesterday we have discussed the same type of question. Okay, so just for recap. So quickly let's move for the next question. What is that? So now we are going to discuss the very interesting topic, that is the collinear points. What is this collinear points about? 3 or more points are said to be collinear if they lie on the same line. 3 or more points are said to be collinear if they lie on the same line. For example, I have a line like this, okay? So this is, let's say point A, this is point B, this is point C. The point A, B, C are here. 3 or more points are said to be collinear if they lie on the same line. They lie on the same line, right? So all these 3 points are collinear. So if you carefully observe how to find whether the 3 given points are collinear, if you carefully see, AB plus BC, AB plus BC should be equal to the total length AC. Length AB plus BC should be equal to the total length AC. That is how you can try to say that these 3 points are collinear. These 3 points are collinear, okay? So you can see here. So the next one, let's try to understand how to find where the points are collinear. Any 3 given points, let's say PQR, whatever the points are. So just try to find the distances, and sum of any 2 distances should be equal to the third distance. If that is correct, you can say that they are collinear. Okay? So moving forward, verify whether the points 1, 5, 2, 3 and minus 2, minus 1 are collinear or not. Let me take this as A, this is B and this is C. So let us try to find what is the value of AB, the distance AB. It is equal to root over x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, 3 minus 5 whole square. So 2 minus 1 is 1, 1 square is 1 plus 3 minus 5 is minus 2 whole square. 3 minus 5 is minus 2 whole square is 4. So 1 plus 4, that is equal to root 5. That is AB. Let's try to find what is BC. So BC is equal to root over minus 2 whole square, minus 2 whole square plus minus 1 3 whole square. Minus 1 3 whole square, correct? Minus 2 is minus 4 whole square, minus 4 whole square is 16 plus this again minus 4 whole square. So that is 16 plus 16, that is 32. Okay, we will leave it as it is. Or if you want to bring this 32, you can write as root over 16 into 2. Root 16 is 4, so we can write that as a 4 root 2. Root 16 is 4, you can write as 4 root 2. Right, this is root 5, that is 4 root 2. Once again, let me check if there is any mistake. AB, 2 minus 1 whole square plus 3 minus 5 whole square, 1 plus 4 root 5. Minus 2, 4 is 16 plus minus 1 minus 3 whole square minus 4. So 16 plus 16 is 32, that is 4 root 2. That is 4 root 2. What about AC? AC will be equal to root over minus 2 minus 1 whole square, minus 2 minus 1 whole square plus minus 1 minus 5 whole square, minus 1 minus 5 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. So minus 2 minus 1 is minus 3 square, minus 3 square is 9 plus minus 1 minus 5 is minus 6 square is 36, which is a root of 45. Which is root 45. So now the point is root 45. Can we write it more? We can write it as 9 into 5, which is a 3 root 5. Which is 3 root 5. Once again, let me check if there is any mistake here. BC. Minus 2 whole square plus minus 1 minus 3 whole square. That's correct. 4 square plus 4 square. Minus 2 whole square, minus 1 minus 3 whole square, minus 4. Right. So as 2 sides are equal, it is enough to say that it forms an isosceles triangle. In case if CA is also equal to root 37, it becomes equilateral. But still, equilateral is also an isosceles triangle. Equilateral is also an isosceles triangle. Okay, so moving forward, show that the following points form an equilateral triangle. So let's try to find what is AB length. Equilateral means all the side lengths are equal. All length of all the sides should be equal. Equilateral, all the side lengths should be equal, right? So what is AB? Root over minus A. Okay, I think it's not required to do all those. These are points on x-axis, but still let's try to do that. Minus A whole square, and 0 minus 0 plus 0 is 0 square. So minus 2A whole square plus 0. So that will give you root over 4A square, which gives you 2A. Now try to find what is BC length. BC is equal to root over x2 minus x1 whole square, 0 minus of minus A whole square, plus y2 minus y1 whole square, A root 3 minus 0 whole square. So that becomes A root 3 whole square. Okay, so that is equal to root over, this is A square plus A square into root 3 square. Root 3 square is 3. So root over 3A square plus A square, that becomes root 4A square. Root 4A square is 2A. Root 4A square, root 4 is 2, root A square is A. So that is again root 2A. So 2A. So these two sides are equal. AB and BC are done. So now let's try to move for the next one. AB, BC are done. Let's move for AC. So AC is equal to AC root of 0 minus A whole square, plus A root 3 minus 0 whole square, So that will give you root A square plus A square into 3 plus A square into 3. That becomes root over 4A square. So again root 4A square is 2A. So now we can say that all the sides AB, BC and AC are equal. We can say AB, BC and CA are equal. So it is enough to say that the given 3 points will form an equilateral triangle as all the 3 sides are equal. Right? So let's move forward for the next one. So please try to copy this quickly so that we can move for the next one. AB, BC and AC, all the 3 sides are equal. Okay. So what is the next one? Show that the points taken in order are the vertices of a rhombus. Find its area. We'll discuss about area later. But find whether it is a rhombus or not. What do you mean by rhombus and how can you differentiate between a rhombus and other quadrilaterals? That we are going to discuss first of all. Okay. So rhombus, all the sides are equal. In rhombus, all the sides are equal. And when I say all the sides are equal, you may try to see that it is a square. No. Rhombus and square has all the sides equal, but diagonals are not equal in rhombus, whereas they are equal in square. Diagonals, this is A, B, C, D. In rhombus, the diagonal AC is not equal to diagonal BD. But in square, all the diagonals are also equal. AC is equal to BC. AC is equal to BD. Okay, but in rhombus, these are not equal. The first thing we need to make sure that is all the sides are equal. So let's try to find all the sides first of all. A, B, C, D. So what is AB? Root over x2 minus x1 whole square minus 1 minus of minus 4 is plus 4 whole square, plus 2 minus of minus 7. So 2 plus 7 whole square. That will give you 4 minus 1 is 3. 3 square is 9 plus 7 plus 2 is 9. 9 square is 81. So that will give you root over 90. One second, please check that. Now let's try to find what is the length of BC. BC is equal to root over 8 minus of minus 1 whole square. 8, so 8 plus 1 whole square plus 5 minus 2 whole square. 5 minus 2 whole square. So 8 plus 1 whole square is 9 square, which is 81. Plus 5 minus 2 is 3 square is 9. That is equal to root 90. Okay. AB is root 90, BC is root 90. I am not doing what is the value of CD and what is the value of AD. You please try to check these two also. I'm assuming that all these four values are equal, all the sides are equal. Let's try to find what is the length of AC. AC 8 minus of minus 4 whole square, 8 plus 4 whole square plus 5 minus of minus 7 whole square, 5 plus 7 whole square, 8 plus 4 is 12 square 144 plus again 12 square 144, that is 2 times of 144, and you know root 144 is 12, so that will give you 12 root 2 centimeters or units, whatever it is. That is the length of diagonal AC. Now we need to find the length of BD, the other diagonal BD. So BD will be equal to 5 minus of minus 1 square. So 5 plus 1 whole square plus minus 4 minus 2 whole square. So minus 4 minus 2 whole square. 5 plus 1 square is 6, 6 square is 36. Plus minus 4 minus 2 is minus 6 square, again it is 36. 36 plus 36 is 2 times of 36, which will give you 6 root 2. One diagonal length is 6 root 2 and the other diagonal length is 12 root 2. So these two are not equal, so we can say that this is forming a rhombus, not a square. All the sides are equal and rhombus diagonals are not equal, so we can say it is a rhombus and not a square. Clear? So please try to copy this quickly. I didn't do CD and AD, but please you try to verify what is the value of CD and AD. Just try to find the distance between the points of CA and AD. Once you find this distance, CD and AD, once you find this distance, you can say whether all the sides are equal or not. If sides are not equal, there itself you can say that it is not forming a rhombus. It is not forming a rhombus, right? So moving ahead, find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. Find the point on the x-axis which is equidistant from these 2 points. So on x-axis means the point will be of the form x, 0. On x-axis, the points of y coordinate will be like 2, 0, 3, 0, 4, 0. Y coordinate will be 0. Y coordinate will be 0, right? So now we need to find one point 2, minus 5 and minus 2, 9. One point something like x, 0, which is equidistant from these 2 points. That means find the distance between these 2 points and these 2 points and equate those two to get the value of x. Right? So let's try to do that. Root over x minus 2 whole square plus 0 minus of minus 5 whole square is 25 is equal to root over x minus of minus 2x plus 2 whole square plus 0 minus 9 whole square is 81. Squaring on both sides, we can try to remove the square root. So we'll get it as x minus 2 whole square plus 25 is equal to x plus 2 whole square plus 81. So this becomes x square minus 4x plus 4 plus 25 is equal to x square plus 4 plus 4x plus 81. So can we cancel x square? Yes, we can cancel x square, but still x is there. X should be there because we need to find the value of x. Okay, so this is minus 4x plus 29. Minus 4x plus 29 is equal to 81 plus 4 is 85. 85 plus 4x. 85 plus 4x. So try to bring all the 4x together and all the constants together. I think we had done some mistake somewhere because we are getting a negative value. Once again, let me cross check that. Find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. X minus 2 whole square plus 25 is equal to x plus 2 whole square plus 81. That's correct. So x square minus 4x plus 4 plus 25 is equal to x square plus 4 plus 4x plus 81. Even this is correct. Minus 4x plus 29 is equal to 85 plus 4x. So bring this 4x here and 85 here. 29 minus 85 is equal to 4x plus 4x. It is equal to 8x. So what is 85 minus 29? 85 minus 29, 15 minus 9, this is 7, so 56 if I'm not wrong, right? So 50 minus 56, minus 56 is equal to 8x, and x is equal to minus 56 by 8, which is equal to minus 7. 7 8s are 56, 8 1s, 8 7s. So the value of x we got as minus 7, and as x is not the distance, x is a point. What is that point? That point is a minus 7 comma 0. Minus 7 comma 0 is a point on the x-axis which is equidistant from both the points. Clear? So I hope you understood this lecture very well, and we have one more question so that we can try, you can try yourself. Okay, it's the same question, right, on the x-axis. So find the radius of the circle whose center is 3 comma 2 and passes through minus 5 comma 6. Find the center of circle whose center is 3 comma 2 and passes through minus 5 comma 6. The distance between these two will become the radius. The distance between these two will become the radius. So you can try that, and you can try to find the radius, find the distance between the 2 points. What is the formula once again? It is root over x2 minus x1 whole square plus y2 minus y1 whole square, correct? So using that relation, you can try to find the distance between these 2 points, which is nothing but the radius of the circle, right? So I hope you understood all these topics about coordinate geometry, right? We have a couple of more concepts that we are going to cover in the next lecture, and I am saying coordinate geometry is very easy as well as a very interesting topic. Okay, so stay tuned to get the next lecture, students. So thank you so much.